Hello all. In this video we will look into operator precedence and how it will work in Java. Most computer languages applies operator preference while evaluating an expression. Let us see a plus b whole square equal to a square plus 2ab plus b square. So here a square plus b square plus 2ab, which is considered as an expression. A square involves two multiplication, one multiplication, a into a. Similarly, b square involves a multiplication, b into b. 2ab involves two multiplication, 2 into a into b. The plus 2ab talks about addition operation. So here an operator precedence plays an important role. Look at the picture here in the left hand side. Here we have specified operator preference in high to low. The top operator you are seeing here is a unary operator, so that plays the highest precedence. Whenever an expression has a minus a or minus b, then that plays highest precedence. Note, the minus will play as a unary or it will play as a binary operator also. So when we look at the expression, we can understand what is the role of minus, whether it is a unary operator or a binary operator. Let us say we are writing an expression like this: int result equal to minus a into b. Here minus is the unary operator, so whatever the value in a, which will be negated. So the minus here operates on single operand a, so we call this as a unary operator in this situation. Once again I am repeating, result equal to minus a into b. Here the minus a, the minus in the letter preceding the a is a unary operator. So if we write like this, result equal to a minus b, then minus here is a binary operator which operates on two operands a and b. So let's go back to the picture again. The unary operator plays first precedence, then the binary operators, which is multiplication, star, division, slash, and the percentage sign for modulus operator. So all plays an equal precedence. Plus and minus also a binary operator which is used for computing an expression, but the precedence comes next to multiplication and division. So the fourth precedence goes to binary operators: greater than, less than, greater than equal to, less than equal to. These are all the comparison operator which we use in evaluating the conditional expression. For example, a greater than or equal to b. So we usually use such a stuff in condition. Say for example, if a greater than or equal to b, then we will make a decision structure. This plays a fourth precedence. The fifth precedence goes to equality and not equality operator. So those are all binary operators. Then the precedence goes to logical, and or operator. So this is useful to combine two comparison operator. Say for example, a greater than or equal to b, and which means the double ampersand, then we will form one more Boolean expression. but the precedence goes to 6th place here. Next to AND, the OR operator takes precedence. That's why whenever we form a conditional expression with an AND and OR combined, if A greater than or equal to B and B greater than or equal to C, or Z equal to 0. So in this case, the AND plays the first precedence, OR operator takes the precedence next to it. The final precedence goes to the assignment operator. So now we talked about the operator precedence which come from highest to lowest. What happens if expression is formed between an operator which is in the same level? Say for example, the third highest precedence goes to plus and minus. So if my expression involves 2 plus operator and 1 minus operator to evaluate an expression, then the precedence is from left to right. So it takes the operator whatever comes in the left position first, then it evaluates the expression in the right next. So let's see an example on this operator precedence. So here, even though we specified 6 or 7 operator precedence levels here, the parenthesis stays on top of this. So even there is a lowest operator precedence, if we place that within parenthesis, the expression within that parenthesis is evaluated first. But however, if within the parenthesis, if there are multiple expressions, then they will be executed according to the law here, highest to lowest. So in simple words, the 3 laws are: first, the parenthesis is given importance, then operator precedence is decided based on high to low, whatever you see here in the left table. Then the third rule goes to left to right. So this comes into picture when there are operator which stays in same level. Say for example, look at the 4th row, greater than, less than, greater than or equal to, or less than or equal to. So if all 4 operators are within an expression, then the rule left to right is applied. Okay, let's go to the next slide and we will look into an example on how it works. So here in this example, first we initialize the 3 variables x, y, z. We have given some values 10, 3, 5. Then we have a variable declared but not initialized, which is a result. Here you see result equal to y minus z plus x. This involves 3 operators. The first operator is minus, the next one is plus, and equality. When you look at the result here, I mean the expression here, the expression is result equal to y minus z plus x. Equal to operator comes first, but it has the lowest precedence. That means in the previous slide, if you see, the precedence for that is in the last. Okay. If you look at the third row, the binary operators plus and minus stays at the same level. So here in the expression also, there are 2 operators. One is minus, which is at third level, plus, which is also at third level. Since the precedence here is equal, the expression is evaluated like this. First, the minus operator is evaluated. That means y minus z is evaluated first. So y is 3 and x is 10. Sorry, y minus z is evaluated first. Y is 3 and z is 5. The result is minus 2 for the first operation. Then the next operation comes into picture. So the next operator is 10. The previous result is minus 2. Minus 2 plus 10, which is 8. So that's why we are getting a result as 8 here. Output is 8. So this example shows how an operator is evaluated when there is an equal precedence. Here plus and minus is at the equal precedence, and we know that assignment is the last precedence, so that's why the result 8 is assigned to the variable result. So that's how the expression is evaluated here, and you are seeing the output as 8. Let's go to the next example. So the same variables x, y, z and result. Here we look at the importance of precedence. As usual, the assignment stays at the last. So when we look at the precedence in the previous example, since minus and plus is at equal precedence, left to right rule is applied, so that minus is executed first, y minus z, then the combined result is operated on plus and added with x. That's how we get 8. Here in this case, the precedence plus is equal, x plus z and z plus y. There are two plus operator here, they stays at equal precedence, but the division operator is one level above. That means it's at level 2. If you see here, star, division and modulus stays on top of plus and minus. This means y minus y, y divided by y is executed first. That means 3 divided by 3 is 1. That is the first expression evaluated here. Now the expression looks like this: x plus z plus 1. Now when we execute the expression, x plus z is evaluated. Now x plus z is 10 plus 5, which is 15. Then one more plus operator is applied. 15 plus y divided by y is already computed, which is 1. So 15 plus 1 equal to 16. So that's how this expression is evaluated. Once again, y divided by y, which is evaluated first, which is 1. Then the expression looks like this: x plus z plus 1. Left to right rule is applied. X plus z is 10 plus 5, 15. Then the plus is appended with 1, which is 16. That's how we get output of 16. Here we saw, in example 2, we saw how the operator precedence comes into picture. But how do we change the precedence in the previous example? Here the expression x plus z plus y divided by y. So we placed a parenthesis. That means even though the division operator is higher precedence than the plus operator within the parenthesis takes highest precedence. That means we are changing the precedence by placing a parenthesis here. However, within this parenthesis, since the 2 operator, 2 plus, which is evaluated based on the left to right rule. That means first x plus z is evaluated, then the result is added with y. So the parenthesis is completed. The overall result is divided by y. So here x plus z is 15. 10 plus 5 is 15. Then it is added with y. 15 plus 3 is 18. 18 divided by y equal to 3, which is 6. So the here output is shown wrongly 16. The correct output is 6. So when we execute this in Java, we will see what is the result. So this is how we can change the precedence. So the result is not 16, it is 6. X plus y plus z is 10 plus 5, then 3, 18. We are dividing that by 3. That means 6. So, as we already told, precedence is respected inside the parenthesis as well. So now we know that division operator on Z is not executed first, but whatever is the operator within the parenthesis, that will be executed first. Even though minus comes, I mean the subtraction operator or minus operation comes first, since the star takes the precedence, first Z into Y is evaluated. So Z into Y is 15. Then x minus 15 equal to minus 5. That is divided by Z, which means minus 5 by 5, and the result is minus 1. So once again, the operator precedence here is Z into Y is evaluated first, then x minus the result of Z into Y. After that, the result of the parenthesis divided by Z. So this is how the operator is evaluated here. Let's go to the fifth example. Here we can even use the nested parenthesis. So in the previous example, if you see, x minus z is evaluated first. Sorry, z into y is evaluated first because the int place, that means the star operator plays the highest precedence, then the minus, that is within this parenthesis. But within this parenthesis, if we want to execute or if you want to evaluate the expression x minus z first, then we will be entered into nested parenthesis. So the first parenthesis is to avoid the division operation, and within the parenthesis there is one more parenthesis for x minus z. This is to avoid the precedence star y. That means here x minus z is evaluated first, then it is multiplied by y. After that, the whole result is divided by z. So that's how we get the output as 3. X minus z is 10 minus 5, which is 5 into 5, sorry, into 3, because y is 3. So 5 into 3 is 15 divided by z, 3. That means z equal to 5. So 15 by 5 is 3. So that's how here the expression is evaluated. So this operator precedence is useful when you are converting a mathematical formula into a single expression. However, one can write it in multiple statements. That means one can write it like this: a result equal to x minus z. Then in the next line, result equal to result into y. And then in the next line, result equal to result by z. So like that, we can split this into 3 statements. But if you know the operator precedence, you can keep a mathematical formula in a single expression like this, because we know what operator needs to be evaluated first, and based on that we will form our expression. Let us see some example. So whatever I explained, so I kept that here in Notepad. Let us first place this in Java and we will see what it executes. So now I'm executing it. If you see, the result is 8. Why? Because y minus z is evaluated first, then the expression, that means y minus z equal to 3 minus 10, which is y minus z 3 minus 5, which is minus 2, then plus x equal to 10. So when we execute this, we will get minus 8. That's what you are seeing here in the output. So all expressions are like this only. So I will place everything here. So if you see, whatever we saw in the slide that we are getting here the result is a 6, not 16. That's a typo on the slide. So that's all here. Thank you for watching. For update on this channel, subscribe the button below the video. Yeah, thanks again for watching. Bye bye.